Hello, organic spectroscopy lovers. This is SS Tripathi welcoming to my channel SST Chemistry. In this organic spectroscopy session, we'll be taking two problems set in the previous GATE 2015. The first problem is like this. The mass spectrum of a dihalo compound shows peaks with relative intensities of 1 is to 2 is to 1 corresponding to m, m plus 2 and m plus 4 peaks respectively, and which is the compound. Now just think for a moment before we discuss the answer. Do you have the answer? Those of you who are quite conversant with mass spectrometry, they can immediately tell the answer. It is nothing other than the dibromo compound. In these four, here there are two chlorine, here there is one chlorine, one bromine, here there is one chlorine, and fluorine is useless. It will not provide or produce M plus 2 peak. It is monoisotopic, but all these three will produce M plus 4 peak in addition to M plus 2 peak. You know, bromine 7981 in the ratio 1 is to 1, a relative abundance. Chlorine 3537 in the ratio 3 is to 1. This is nature's creation. So if there are two bromine atoms in a molecule, then it will show both M plus 2 and M plus 4 peak. So also bromine and chlorine. So also 2 chlorine. All these three will show M plus 2 peak due to the presence of one higher isotope, and M plus 4 peak due to the presence of both the higher isotope. I have given you an example of a dichloro compound where this is the M peak. The molecular mass takes into account the lower isotope, which is usually the most abundant isotope. In case of bromine, the two isotopes are equally abundant, 1 is to 1. So the M peak is contributed by the lower isotope, most abundant lower isotope, and this is 98, and 2 units mass units ahead is M plus 2 due to one bromine or one chlorine. There may be 3, 4, 5, 6 bromine or chlorine, but only for one chlorine 37, one bromine 81, you will get this M plus 2 peak. All others are lower isotope. And M plus 4 peak, it is due to the presence of both higher isotopes, both bromine 81, both chlorine 37, one chlorine 37, one bromine 81 together. And you find these isotope peaks, which are to the right of the M peak, they are prominent. Particularly the M plus 2 peak is highly prominent if there is a chlorine bromine, at least one chlorine bromine atom. If there is one bromine, it will be 1 is to 1. M peak height and the M plus 2 peak height will be same, nearly same. If it is one chlorine, then 1/3, 33.33% of the M peak. And if there are two chlorine, two bromine, or one chlorine and one bromine, there will be M plus 4 peak, but its probability will be less. And to find out the probability, we have a simple formula. You know, A plus B to the power n. N stands for the number of chlorine atoms or number of bromine atoms. A and B stand for the relative abundance. 1 is to 1 for bromine, 3 is to 1 for chlorine. And if there is one chlorine, there will be only one M plus 2 peak, one isotope peak. I'm not discussing about M plus 1 peak. I'm discussing about M plus 2, M plus 4. So M plus 2 and M, that is in the ratio 3 is to 1. Because the power is 1, so A plus B, A is 3, B is 1. Or 100 is to 33.33. And if there is one bromine, then same A plus B to the power 1, and it is 1 is to 1, 100 is to 100. They are of same height. If there are two chlorine atoms, then there will be M plus 4 peak in addition to M plus 2 peak. These are the two isotope peaks, and the ratio between these three peaks, including the M peak, will be A plus B square, and it will be A square plus 2AB plus B square. And if you put A is equal to 3 and B is equal to 1, you will find the ratio is 9 is to 6 is to 1. And if you convert to percent of the M peak, it will be 100 is to 66.67 is to 11.11. And if there are two bromine, then the same A square plus 2AB B square, put A and B as 1, 1, you will find 1:2:1. That means the M plus 2 peak will be the double of the M peak, and the M plus 4 peak will be of almost same size as the M peak. So obviously the question says about 1:2:1. The question says about 1:2:1. So therefore, the correct answer is the presence of two bromine atoms. I have also shown the presence of one chlorine and one bromine would give the ratio as 3:4:1, because that is a separate formula. A plus B to the power n, n stands for number of chlorine, here it is 1, into C plus D to the power m, m is the number of bromine, here also equal to 1. And you multiply these two and then group it, the middle two terms, and it will be coming 3. Put A is equal to 3, B is equal to 1, C is equal to 1, D is equal to 1. This is for bromine, this is for chlorine. And if you put them, it will come 3:4:1. 100:133.33:33. This 3:4:1 is not given in the question. So the possibility of one chlorine and one bromine is ruled out. This is ruled out. Had it been 2 chlorine, then the ratio would have been 9:6:1, not given. So 1:2:1 correctly fits this particular structure. So the correct answer is this. Then let us discuss the second question. It goes like this. The Beckmann rearrangement of a bromoacetophenone oxime gives a major product having the following proton NMR. 1 proton singlet 9.89 ppm, 1 proton singlet 7.88, 1 proton doublet 7.45 with a coupling constant around 7 Hz, 1 proton triplet at 7.27, 1 proton doublet with 7.12 ppm with a coupling constant around 7 Hz, and 2.06 ppm 3 proton singlet. These four in the aromatic region from 7.88 to 7.12, these 4 1 proton peaks, they are for the aromatic. There are 4 non-equivalent aromatic protons, and the possible compounds which will represent this proton NMR data is which one? Is it a bromo derivative of N-phenyl acetamide or acetanilide? This is meta, this is ortho, or it is a bromo derivative of N-methyl benzamide, ortho or meta. So let us go for the Beckmann rearrangement of acetophenone oxime. The key for this rearrangement is the transmigration, and there are 2 geometrical isomers E and Z. So if you take the E oxime, these two are opposite, and perform the Beckmann rearrangement, you will find this phenyl will migrate and you will get N-phenyl acetamide, or we call acetanilide. Forget about the bromine part. That is there in the beginning and it will be there at the end. We will place the bromine at the appropriate time looking to the proton NMR data. But if it is a Z oxime, then methyl will transmigrate, and it will be N-methyl benzamide. So out of the two, which one is the correct structure which will give this proton NMR data? We first look to this 2.06 singlet 3 proton, which is for a methyl group. This methyl singlet is undoubtedly for CH3CONH, this one. CH3 adjacent to C double bond ONH, that is a singlet. But if it is CH3NH C double bond OR, CH3 is adjacent to NH, C double bond O, not only it will be having a more downfield desilted peak, methyl peak, and if you look to the correlation chart, you will find this methyl adjacent to NH C double bond OR will be around 3 ppm, while this CH3 adjacent to C double bond ONHR will be around 2 ppm, and moreover it will be a singlet and this will be a doublet, because these secondary amides, they have very slow rate of exchange, NH proton exchange, so they do couple. The methyl will be a doublet. but you are getting a singlet, and that too at 2.04. That without any iota of doubt proves that it is an phenylacetamide derivative. So we reject these two. It cannot be an methyl benzamide derivative. So out of these two, now we shall fit in the bromine at ortho or meta. Now look to the other data. Of course, the one proton singlet at 9.89 is due to the NH proton peak. We can also say that the benzamide is ruled out because in benzamide the NH proton will not have its peak exceeding 8.5 ppm. But in case of N-phenyl, this NH, the lone pair is directly bonded to the benzene ring, not only to the carbonyl group but also to the benzene ring. So the extent of desilting of the lone pair is more, and therefore the proton will be more desilted, and it is giving at 9.89. Had it been this compound, then the lone pair is not directly bonded to the benzene ring. So the extent of desilting that it is doing is less. This is about 8.5, but this is 9.89. Highly desilted NH environment. This is not highly desilted NH environment. So this is less than 8.5, but in our case it is 9.89, which also proves complementary proof. This compound, this is N-phenyl compound, not the N-methyl compound. Then coming back to the placement of bromine, we will do it very easily. You see, if it is meta, then this proton will give a singlet. You are getting one proton singlet in this at 7.88. So in ortho compound, there will be no singlet. If you just look to the ortho, this is a doublet, this is a triplet, this is also a triplet, and this is a doublet. Forget about J4, J5, which will not be visible in low resolution NMR spectrum. In only high resolution NMR, we expect J4 and J5, and the data is given as 7 Hz, which is J3. The singlet data will never appear here in the aromatic region, all multiplate. And moreover, it is flanked by two desilting group. The increment for this is about 0.2, 0.3, and this bromine is about 0.2. So the high 7.88 value will not be found in this case, in this or on this. It will be nearing 7.5 or 7.4. But 7.88 and a singlet also speaks 100% in favor of the meta, not ortho. So the correct answer is this. How did you like? If you have liked, hit the like button. Why you are so miser? And if have not subscribed, subscribe to my channel. I'll be producing regular videos on organic spectroscopy, which will benefit you not only for your net gate study or your examination, but also for research level in organic chemistry. Bye.